Hello everyone, my name is Konstantinos Guzakov, and in this short teaser video I'd like to present to you my master thesis topic and results with the title BPMN for process support in Generated Assistive Systems. The main goal of our research was to generate an assistive system using MontaGem. It is going to rely on BPMN models represented in textual form for planning the order and flow of individual steps in an assistive process. The problem we were aiming to solve was adding support for modeling advanced assistive processes. Usually, assistive systems support different domain-specific tasks, such as finding or filling tasks that are defined sequentially. However, often real-life assistive processes are more complex and contain a lot of tasks that can be performed concurrently. Moreover, it might be possible to reach the goal in multiple ways based on the user preferences. To tackle these problems, we introduce BPMN models in assistive systems to delegate and enhance process support. Before we dive into the actual implementation, let's have a quick overview of the basic concepts which are necessary for further understanding. First of all, we are dealing with assistive systems. Assistive systems are information systems that provide situational support for human behavior based on stored information and real-time monitored context. The main actor of such systems is the assisted person, who can interact with the system via sensors and receive assistance via supported devices. The main question is how to then generate assistive systems. In order to generate such systems, we are using a model-driven software engineering approach. This is a software development methodology that focuses on creating and exploiting domain models as an integral part for the creation of the final system. The model-driven engineering framework that we're using is MontaGem. One of the key benefits of this framework is that it allows the generation of large parts of an application, both front-end and back-end, based on domain models provided in textual form, such as class diagrams. As a result, it saves a lot of time for the developers and speeds up the overall development process. In our work, we considered assistive systems as an example. Assistive Kitchen is a MontaGem application that provides situational support to humans in the kitchen. The system takes into account the user goal, for example a cooking recipe, and the kitchen environment, namely the available resources, ingredients, and appliances. Based on this information and the user actions, the system plans assistive tasks and guides the user through the whole process. The cooking recipe process can be further divided into individual steps or tasks. These tasks are domain-specific. For instance, in our kitchen example, it is possible to specify filling, finding, or placing tasks. Note that these tasks might differ depending on the assistive system's peculiarities. Also, the assistive information can be presented to the assisted person in different forms, such as text, audio, or image. For our assistive system to be fully functional and compatible for advanced assistive processes, 3 models are expected, each with a clear scope. The first model is the kitchen definition. This model is provided in Assistive System Definition DSL and specifies the kitchen environment. For instance, it defines what ingredients, resources are available, where to find them, and how to use them. Next model is the task definition. This model is written in Task Definition DSL and defines the description of individual steps in a cooking process. While the first 2 models were already part of the existing Assistive Kitchen implementation, we incorporated a third model to allow modeling complex processes. The Task Flow Definitions model specifies the order of the task defined by the Task Definition model that we mentioned earlier. This model is represented in Workflow Model DSL, which is the BPMN equivalent in Monticore. Here we can see the overall architecture of our system. The starting point of the system is the modeling and generation of assistive process in the BPMN format by a domain expert. There are many tools available for modeling and exporting BPMN workflows, such as Camunda. Once the BPMN model is exported in XML format, we can use the BPMN translation application to automatically convert the model into workflow model, which is the process format expected by our assistive kitchen. Lastly, all three models, kitchen definition, task definition, and task flow definition, can be consumed by the assistive kitchen to provide cooking assistance to users via generated user interface. As already mentioned, the starting point of our system is modeling the assistive process in BPMN. Here, we can see an example of cooking recipe that was modeled using Kawerma, which is a Camunda web tool for modeling business processes. The modeled process can then be exported in XML format. We can use the BPMN translation application to convert from the BPMN from XML format to the corresponding workflow model. Next, we need to import our domain models into Assistive Kitchen. First, we specify the kitchen definition model that defines the available resources such as machines, storages, and ingredients. Then we have the task flow definition model that specifies the descriptions of each individual tasks in the cooking process. Last but not least, we have the task flow definition model that specifies the order of tasks in the cooking process. Now, in order to start the application, first we need to compile our models and domain-specific languages, and then start the backend and the front application. Once done, our assistive system is ready for use. The user sees the available assistive information and can interact with the system by completing tasks or by returning to a previous state if necessary.